Hi, I'm Masato Minda, working at Japan Registry Services. Now I will talk about GRU issue of DNS. First of all, I would like to talk about JP domain, JP name servers, and our company. JPRS is the abbreviation of Japan Registry Services. JPRS is operating JP registry system. JPRS is managing and administrating .jp-TLD. JPDNS are the authoritative name servers of .jp. JPDNS are operated by JPRS and other organizations. These are 6 servers from A to f.dns.jp. JPDNS have 64 zones. JP, this is the top-level domain of JP. JP is for general use, such as personal use, brand name, and so on. JP can set the Japanese domain name by Punicode. These are organizational type of JP domain name. Academic, administrative, this means a member of JPNIC, corporate, group, local government, network, and organizations. Oh, sorry. Tokyo.jp, Osaka.jp, Kyoto.jp, and others are geographic type of JP domain name. Definition of terms. In bailiwick name server is FQDN with their domain to name server. Out of bailiwick name server is FQDN with outside domain to name server. And this slide, this presentation, CNS means abbreviation of caching name server. And ANS is abbreviation of authoritative name server. In NANOG presentation guideline, slide must use at least 28 point fonts. Now main subject. JPDN sent the way of handling GRU in June 2004. All of out-bailiwick GRU are deleted from JPDNS. Before June 2004, JPDNS JPDNS responds NSRR with its GRU automatically in any occasion. After this change, JPDNS responds NSRR with GRU only when the host name of NSRR is accompanied with the parent domain. Oh, yeah. Our changes are technically correct. This is described at section 6.1 in RFC 2181. However, the problem occurs. Some domains encounter difficulties in name resolution. People client cannot connect to www.example.jp. Of course, these were an inquiry in JPRS from ISP. This website is one of the most famous websites in Japan. This issue is affected with this change, with our change, sorry. Now, GRU handling in JPDNS. This is case A. NSRR is internal hostname accompanied with its domain, which belongs to the same zone. For example, domain example.co.jp, example.co.jp in NS, ns.example.co.jp, ns.example.co.jp in 10.10.10.10. JPDNs can provide ns.example.jp as NSRR within its group 10.10.10 when the caching name server sends the query of ARR for www.example.co.jp to JPDNS. Example.co.jp uses invariant names for its name server. This is case B1, gluelessness. NSRR is host name belongs to a different zone. For example, example.co.jp in ns.example.ne.jp. The JPDNs can provide only NSRR and cannot provide the glue of NSRR. Authoritative name server on binary sometimes responds glue on this case according to the occasion. This is case B2. One of NSRR is hostname belongs to the same zone and has different. For example, example.co.jp uses xx.example-xx.co.jp for its name server, but example-xx.co.jp uses ns.example-xx.co.jp for its name server. In this case, JPDNs can provide only NSRR. Issues of caching name server with bind rate. First, caching name server with bind rate up to version 8.2.7. Caching name server fails in name resolution when if it receives the result of a query without glue twice continuously. This is very serious. Caching name server with bind rate version 8.3.0 or later. Bind 8.3.0 or later can resolve domain name. However, it depends on the retry query from the client, DNS client. In this case, name resolution becomes slower. It takes 5 to 10 seconds. But the effective cache makes it be unaware. Implementation of well-known software for caching name servers. Bind9 has no problem. DNS cache has no problem. And the DNS server on Windows 2000 server has no problem. I think that DNS server on Windows Server 2003 is perhaps safe. However, gluelessness causes another issue. This will be explained afterwards. These are statistics of gluelessness before and after at June 2004. Yeah. Oh, okay. And the first column, this field is the frequency of query when caching name server sent to JPDNs until obtained glue. The part in red characters have a problem. Before June 2004, Bind9 on JPDNs already had a problem, but most of JPDNs use Bind8. Bind8 is predominant. Only one predominant. Only one of JPDNs uses Bind9. So this part, 0.083% of domain have a problem. after June 2004, 0.083% fails in name resolution from old bind-to-8 on caching name server. Also, 0.083% is quite a small rate. It might be a big problem if the domain frequently accessed, including in this minority rate. Old bind-to-8 on caching name server still prevails. This is a common example at ISP setting in JP. Many ISP have two domains. One is ne.jp, which is for services to customers. The other is ad.jp, which is for administration use. ISP's domains are example.ne.jp and example.ad.jp, and customer's domain is example.co.jp. NSRR set to customer's domain is covered with the domain for service use. Example.co.jp in ns.example.ne.jp. ISP service is covered with domain for administration use. Example.ne.jp in ns.example.ad.jp. Administrative domain is covered with the domain for administration use. Example.ad.jp in ns.example.ad.jp. ns.example.ad.jp in 10.10.10.10. In this case, old bind-to-8 on caching name server cannot resolve example.co.jp. Here is current approach of JPRS. Propagation and activity to recommended ISP's configuration of NSRR with parent domain. If the ISP uses out-of-bailiwick name server, the ISP should change to in-bailiwick name server. JPRS is looking for another solution because JPDNs can not upgrade to bind9 at this stage. Next, there's another issue in gluelessness. Here is the in-bailiwick name server. Query of ARR for www.example.jp when ns.example.jp is configured to NSRR for example.jp. First, caching name server refer to root name server, IP address of www.example.jp, and receive hostname and group for JPDNS. Second, caching name server refer to JPDNS, IP address of www.example.jp, and receive the hostname of NSRR, ns.example.jp, of example.jp and its group. Third, caching name server refer IP address of www.example.jp to ns.example.jp and receive it. Three times of reference to authoritative name server are required. This is only 3 times. Here is out-of-bailiwick name servers. These are many repeat things, so skip next. But in this part, this second part, gluelessness has happened. And in this case, 6 times the reference to authoritative name server and required. Of course, 6 times is many times than 3. There are live examples. These settings are by our name server. First example is www.good.co.dnslab.jp. This domain has no problem. It gets the IP address immediately. Second example is www.bad1.co.dnslab.jp. Resolving this domain has one glue-lessness. Bind it on caching name server can resolve this domain, but it takes time about a few seconds. Third example is www.bad2.co.dnslab.jp. Resolving this domain has glue-lessness continuously twice. All the bind it on caching name server cannot resolve this domain. All TTL are set at 20 seconds. If we try this example, experiment query should be sent at interval of 20 seconds. Now summary. When NSRR has no glue, caching name server need to access to many authoritative name servers. It causes name resolution becomes slow. Increase of traffic for the DNS query, and decline of stability, reliability, and maintainability in a trouble. And this is important thing. When DNS query ends in glue-lessness for NSRR continuously twice, bind 8.2 and older on caching name server fails in name resolution. Main subject was done. Now I'll talk about APA domain. APA domain have the same problem. Many people know that reverse DNS lookup in other APA zone is slow. People suppose the case is issue of name delegation. This is not correct. Actual case of glue-lessness issue given to bind it on caching name server. Most of name server in APA zone are out of bailiwick names, and this causes glue-lessness. Bind 9 can make reverse DNS lookup much faster than bind 8 in most cases. Glue is not recommended on this point of DNS operation. If E146.APA is used practically in the near future, it will become a big problem. For example, using ns.1.8.e164.APA is much better than a.dns.jp. This discussion is not NANOG. I think IDF is a better path. Here is ISC response. This is a comment from ISC. This is a problem caused by older bind 8 and bind 4. All known workarounds involve probing more glue. Embedded glue is an appropriate workaround. Additional cybering glue might also help. Easy. If a delegation from .co.jp include ns in foo.bar.ne.jp, include glue for foo.bar.ne.jp in the .co.jp zone. We regret this inconvenience. That's all.
Thank you very much. I have a couple questions for you. First, how many complaints did you get of slowdown before you put in the glue-lessness? How did you discover the slowdown in the DNS servers?
How many? Only one has big trouble. But many people did not, なんだ、did not,
Go ahead and help. Thank you.
sorry. ごめんどうしよう。あれだよ。今いくつだよ。トラブル起きたかったけど。すぐで、どういう反応したかと。ああ、そうか。その時はまだだから原因がよく分かってなかった。その後これは。
When that occurs, we did not know exact the cause or the reason, so we could not respond correctly at that time. And afterwards, we searched and get this result. And 結果得てからどうしたんですか？結果得てからは正しく。
で一応そこは直し直接ベリーにしてもらった。なるほど。
Yeah. Now, after we found that reason, we asked the owner of the website and to change the GRU records. Yeah.
Good. Would you, on the in bailiwick results, when you put it in and you saw the improvement, how many people were told about it?
Well, last December we had the conference in Japan. At the time, the audience of this presentation made a very big response to us. It's very interesting.
Good. And have many people also looked at the other IRC response, which is additional siblings?
他にどれぐらいそういうのを見つけたのかっていうか、どれぐらい自分もそういうのがあるとかいう反応があったのか。
ちょっとまだ言い始めて2ヶ月だもんね。
Oh, yeah. We started to say this kind of things to the people in Japan. So not so many people are checked their configuration of the DNS servers. So we have not got the answers or the correct response to from the people. Yeah.
Okay, thank you. There'll be another question behind me.
Yes, thank you for the presentation. My name is Ed Lewis. I work for Newstar. I worked in DNS for quite a while, and I've seen the same problem in a couple places. It's a fairly big problem because the DNS protocol can screw itself up, and this is one example of how it happens. What I really want to come here and say is that at the end you talked about the IETF and NANOG and the discussion back and forth. This is a case where people in the operator community really need to pay attention to what the IETF is saying about these kind of issues, because on the one hand, we're working on DNS protocol and trying to extend it. And in cleaning things up, like cleaning up this glue situation here, we've created operational issues for the operational community as a protocol engineer. It's interesting to come over to the operations side and see the impacts of these cleaned up protocols. In this case, part of it is implementations in the past haven't done the exact right job all the way through there. For example, in Bind 8, we know that it gets lost trying to find answers, and that's what's happening. In Bind 9, they fixed how they look for stuff. So this is a case where implementations have gotten better. That's why 8 to 9 is getting better for this. But continually in the operational community, when things like this happen, it's important that people look at things that happen, for example, in the IETF's DNS operations working group, DNS op, where these kind of discussions will really help go back to the protocol engineers and say, we have to improve things there too. So.
Thank you for your comments. We totally agree with your ideas.
Spencer Dawkins, and you mentioned that one of the problems you were seeing was when you were looking at E164.ARPA, and this is maybe as much for the people in the room as anybody else, but North America numbering plan country code 1 has not been delegated yet for E164 ARPA, but that's actually supposed to happen in like January 2006. So it's something that may be affecting people in the room a lot more in the coming year than they're thinking about now.
Okay, thank you.